So hello folks, in this video we'll go over basic recursion, some basic stuff. It's not too much advanced or anything like that. So I already solved it and I think I did like 2 weeks ago. So I should be off. So I've just renamed the recurse to recurse back. Now I'll be trying out recurse.py. So here's those something rabbit pair, classic various, filter, recursive, GCD, and palindrome and factorial are pretty easy. So what I'll do is list that file, yeah, same stuff that which I already did that. It's my previous command. All the failures, factorial is a failure, filter recursive is a failure, GCD is a failure, yada yada yada. So let's go over here, maybe all the way from here to here. I mean, every function commented out. Now it says okay. Now let me try uncommenting out factorial. So yeah, it's failing. So factorial is very easy. You write base case. The base case is if n is 0 or 1, it's 1, right? So n less than or equals to 1, return 1, else return fib. Sorry, it's factorial. Okay, this editor, I don't like this, but anyway, so n minus 1 and wait, this is factorial. Why am I wired to do Fibonacci, right? So it's n into n minus 1. So pretty nice spacing there, but okay. So yeah, so that is it with factorial. Let's move on to palindrome. So what is this? Determine if given phrase is a palindrome. As a stretch goal, support phrases such as a man and canal. Okay, so we want to support cases, right? So pretty much this is also easy one. All you have to do is check the first and check the last, right? So if they are same, move on to the inner subset and go all the way until you reach the innermost one. So innermost, you have the base case that we are talking here. Can have all the way in the middle, if odd number of characters, you'll be left with only one, and sure enough, it's a palindrome. And if it's maybe like 2, right, or even 0, 0 is also fine. So 0 is palindrome. Now I got to know about 0 after watching the video, but even then, so just either compare if the string length is 2, just compare the both one and return from there. If it's just 1, just return true because it's a palindrome. So that's what I'll do. So the base case is if length of letters is 1, return true. If length of letters is 2, right? I mean, this is not a good code, but this is how I wrote, so I'm keeping it authentic. I'm not copying the solution or something. This is how I did it. So letters of 0 dot lower gives you or let me check IPython. This is classic REPL driven development. A equals hello and a dot lower. Okay, it's lower. Equals letters of 1 dot lower, and that's it. It's a boolean expression, so it should you should evaluate to either true or false, and then you have to return that. Almost forgot that. Return. Well, if not, Right, so first character is letters of 0. Okay, last character is letters of -1. So if first char dot lower not equals to uh, last char dot lower, then you return false because it's clearly not the same. If not, you return palindrome of letters 1 all the way to -1. So -1 is exclusive. It means that the last character is not included, right? I could show you. Here is a, sorry for my terminal beep, uh, from 1 to -1. So yeah, first and last excluding, and you just pass on the remaining. Now just save it. Okay, it's saying okay. So if I return false here, it fails. So just reactive feedback is good, so it works. Now here's GCD. I think I kind of solved it in before an exercise before or something. So yeah, reading this. So let me. I don't know how this works. So AB approaches repeatedly subtract smaller number from the larger one until no longer possible. If the remainder is 0, the smaller number should be the GCD. Otherwise, repeat the process using the new larger number and the remainder as the small number. Okay, so getting rid of paths. If A is greater than B or B is greater than A, right? So we receive yeah, A and B. Now this is called as inverting. So return GCD of A comma B. So this why we do that is, I mean, at least what I caught is, instead of putting like a lot of complex if and else, just make sure that the input A will be always larger number and B is always a smaller number, right? Now A is larger, right? So what happens is, one second, let me reread this. Repeatedly subtract smaller number from the larger one until no longer possible. Okay. If the remainder is 0, then the smaller number must be GCD. Okay. If A modulus B is 0, return B because B is the smaller one. If not, so let me go back. Otherwise, repeat the process. Subtracting as the new larger number and remainder as the smaller number. If remainder is 0, then smaller number will be the GCD. Okay. Otherwise, repeat the process using the number you were subtracting as the new larger. What does it mean? Okay, let's see some examples. 1071462 taken from Wikipedia. Subtracting 462 twice from leaves a remainder of 147. Okay. Okay, 43 times. Okay. So let me just track down. So there is 1071 and 462. So 1071 is it modulus 462. So that is reminder is 147. Right? Okay. So the thing I got the guessed, it's that you just return the first number will be the smaller number and the other will be the reminder. Okay, maximum recursion. Okay, okay. So I think there must be some other kind of base case. Uh, because this is not always true. Um, let's see. 1071,462 subtracting 21 dies from 147 leaves a remainder of 0. So if 21 divides is a greater, let's just see what happens if 7 and 3, right? So the remainder of 7, okay, 3, clearly there is no 1 should be the uh, HCF or GCD here. It's like 3 into 2 plus 1, right? So the remainder here is 1, 3 and 1. And what happens here is okay, I'm gonna read it again. Determine greatest common divisor for two integers a and b. One approach is describing Euclid elements roughly as repeatedly subtract smaller number from the larger number until no longer possible. Okay. If the remainder is 0, then the smaller will be the GCD. The remainder is 0, the smaller is the GCD. Okay. Repeatedly subtract larger, repeatedly subtract smaller number from the larger one until, okay, right. So if b is greater than a, this is b comma a. Yeah, I did a mistake here, so I was not really inverting. I was like blindly doing something, maybe. So here it is, and I guess this should do the job. Gladly it did. And let's move on to filter recursive. Filter iter again. Okay. Okay, get rid of this. So XS, right. Okay. I think I'll define inner filter XS and maybe store, I'm not sure. Store equals none. Okay, maybe my filter because filter is built in, and underscore for styling purposes. If store is none, store is a container. If not XS, that there's no elements, return store, I mean there's no element at all, so we just return whatever we have accumulated so far. If not, okay, we'll test out, or maybe for fancy purposes we can do like return my filter of function excess of 1 to this, and excess plus excess of 0, which means I'm appending the first element if function of excess of 0. This means if that function that we are trying to filter on, if it gives a true value, we'll do this, right? If not, same stuff, but we just move on without adding it. So this is just excess. We are not going to add it if it fails. So, and should be good to go. And there's a failure. We'll see why, because I'm not calling this return my filter. Just pass on f and excess. Again, there's 2 failures. Why? If store is none, store equals that. Okay, let's see why it's failing. Got 2 expected. Okay. One sec. Yeah, return my filter f1 excess. Is it because of reference? Filter recursive lambda x false. That's right. So if it's false, it should not filter anything. Why is it filtering 2? Okay. If there's no excess, return store. That's right. If store is none, store is a list. Now filter f excess, same thing, function x of from 1 to all the way, if excess. Interesting. I'm gonna put store up here just to try out my theory, and there's no store, there's no this, there's no that. If function of excess of 0 so if not excess, just return store. If the first thing gets evaluated to true, you just add it. Okay, I get it now. That's not excess, so let me just roll back. So it was fine. Now this is store. uh, is just store, so we are not adding. Uh, got nothing, expected something. Wait, store plus this, that's right. Something is not working here. Yeah, I'm supposed to call this. Sorry. My filter function access, sorry. At last. And then there's radius. I know this from memory by doing the previous exercise. Uh, right. So if there is no excess, just return the init, right? If there's no init, okay, just return radius again with same function, but from the all the way till the end, but init will be the first one, which is 0. If not, return. Now what happens is we are reducing and we need to apply function. Uh, Now it will be f of uh, okay, it's not gonna be in it. Ooh. This will be the the last one, is it? Because wait, we need to apply the innermost first, and then the uh, yeah, we need to apply the innermost. Wait, yeah. So I'm choosing the first here because I'm badly guessing my from my memory. But what I'm trying to do is to apply this function. The first one, let's just do the same thing again. If I were to add these numbers, what I would do is 1 plus 2, right, plus 3, and plus 4 in the end. So it means that I need to apply 4 all the way last and then reduce. Same reduction with same function and excess, except the last, and just pass on in it. And that's it. So import doc test, what happened now? Something happened. It's not printing, okay, for some reason. Okay. I'm going to revert back a few things. Maybe it's endless recursion there or something. Is it still okay? It's still there. So this is the last one, and it's the radius. And same f and same excess, but 1 except minus 1, which is the last, and same pass on in it. And that's it. So 3 failures. str does not support item assignment. Okay, so let's just see which is failing. uh so all the way, right? So if there's no excess, you just return in it. Now this will return in it and applies the last element, which is the okay, this should work. 1 sec. Okay, yes, or even you can do this way. Now would it fix if I just reverse the order? It did not. There's 1 failure. Okay, now it's been a while, so a lot of not lot but 1 abstractions, and now that's reducing. So if not excess, you return in it. That's about right. If not in it, reduce f. Let me see if the args are correct. Excess, except the last, and in it will be the last. Okay, return f, reduce f, pass on the function, and except the last, because the last is getting consumed here, and you pass in it. Now is it rabbit pairs? No. So let me read I'm not familiar with this thing. Let's see which is that. Reduce mirror, foo bar. Let's drag that out. So what happens is that it requires, okay, so the tracking down of this would be foo and bar, right? So init is this. Got it. So this is not init, it's none, because not this always evaluates to that. That's why. So I was supposed to do this. Now I realize that I don't need to. Or maybe is none, whatever. We got it there. Let's move on to rabbit pairs. It's good to do things live. I know I did that, but still, it's been a while. Feels like I don't know what I'm doing, but somehow it's progressing. A newly born pair of rabbits are placed in a field at age of 1 month. Now, when I read this, it didn't really occur to me immediately, but I know this is fancy way of saying Fibonacci sequence. So the first one is first, 1, and 2 is 1, and 3 is like you add up, which is you add 1 plus 1, that results in 2 here, and for getting 3, which is 2 and 1. So here it is. For number 2 and number 1, you just return 1. The base case is clear. If n is less than 2 or equals to 2, right, you return 1. If not, return rabbit pairs of n minus 1 plus rabbit pairs of n minus 2. Voila, that's it. I meant to say that's it. And it's easy, but somehow there are certain things. It's not clear right off the bat, but I did the same blunder multiple times. Now I was able to catch that. And if this is too confusing, so let's just reduce this like this: f of x s of 0. Just return this. If not, return that. So this should be easy to parse while reading code, and it's passing. Thank you.